Hi everyone, I am A. Gayatri Acharya, Assistant Professor in CSC Department. Welcome you all to my video creation activity based on operating system. The topic of this video is segmentation. Segmentation is an important aspect of memory management that became unavoidable with paging, which is the separation of user's view of memory and the actual physical memory. In short, it is a memory management scheme that supports user view of memory. This is an example of logical address. A logical address space is a collection of segments. For example, subroutine, array, or a data area. Every program or job is a collection of these segments. Each segment has a name and a length. The address of the segment specifies both segment name and offset within the segment. For example, the length of the segment main is 100 KB. Main is the name of the segment. The operating system serves the entire main memory for the free space to load a segment. Generally, mapping is done by segment table. A segment table is a table where each entry of the segment table has a segment base and a segment limit. The segment base contains the starting physical address where the segment resides in memory, and the segment limit specifies the length of the segment. This is an example of segmentation hardware. From this diagram, the logical address consists of two parts, a segment number S and an offset into that segment D. The segment number is used as an index to the segment table. The offset D of the logical address must be between 0 and the segment limit. The segment table is essentially an array of base limit register pairs. If the offset D of the logical address is not in the range or limit, then we trap to the operating system. When an offset is legal, it is added to the segment base to produce the address in physical memory of the desired byte. So, the segment table must have an array of base limit register pair. Let's take an example. In this example, the logical address space or a job is divided into 4 segments numbered from 0 to 3. Each segment has an entry in the segment table. The limit specifies the size of the segment and the base specifies the starting address of the segment. In this diagram, segment 0 loaded in the main memory from 1500 KB to 2500 KB. So 1500 KB is the base and the difference between 2500 and 1500, that is 1000 KB, is the limit. Various advantages of segmentation are: it eliminates fragmentation. It means by moving segments around, fragmentation memory space can be combined into a single free area. It supports virtual memory. Also, it allows dynamically growing segments and facilitates shared segments. And it supports dynamic linking and loading of the segments. Now let's discuss segmentation with paging and the comparison between segmentation and paging. Let's start with segmentation with paging. It based on page the segment. Each segment in the scheme divided into pages, and each segment maintains a page table. The logical address divided into 3 parts, that is S, P, D, where S is segment number, P is page number, and D is displacement or offset. The advantage of this scheme is it avoids fragmentation. and support user view of memory. Now let's discuss about protection. In paging memory management scheme, the operating system provides protection bits that are associated with each frame. Generally, these bits are kept in page table. These bits are called valid or not valid bit. Particular page loaded in memory if the bit shows valid, and page is not valid in the processor's logical address space, then it is called invalid or not valid bit. Now let's see the comparison between paging and segmentation. In paging, main memory partition into frames or blocks. In segmentation, main memory partition into segments. In paging, logical address space divided into pages by compiler or MMU, whereas in segmentation, logical address space divided into segments specified by the programmer. In paging, this scheme suffers from internal fragmentation or page break, whereas segmentation is not suffers from external fragmentation or page break. In paging, OS maintains a free frame list with not to search for free frame, whereas segmentation, OS maintains a particular of available memory. In paging, the OS maintains a page map table for mapping between frames and pages, whereas in segmentation, the OS maintains a segment map table for mapping. In paging, it doesn't support the user view of memory, whereas segmentation supports the user view of memory. In paging, the processor uses the page number and the displacement to calculate absolute addresses, that is P and D, whereas in segmentation, processors uses the segment number and displacement to calculate the absolute address, that is S and D. This is a comparison between paging and segmentation. Now let's talk about TLB. TLB stands for Translation Look Aside Buffer. Act like a cache and contains page table entries, and that entries must have been recently used or frequently used. Whenever the processor needs to access a particular page, it searches the TLB. If the desired page table entry is present in the TLB, it is said to be TLB hit. Otherwise, it's called TLB miss. Then the processor searches the page map table for corresponding page table entry. Thank you.